my talk will be give you some highlight on the technical component on how we really deal with load-bearing masonry structures, and I'll focus inshallah على historic structures. I have experience in dealing with historic structures in different parts of the world, including Egypt, Iran, Turkey, and other parts. I recently have a textbook that's published. Let me see. This textbook here, published actually less than a year ago. My co-author is Mike Schuler, who is a principal of Atkinson, Nolan and Associates in Boulder, Colorado. It's a consulting firm that maybe it is the top consulting firm in the U.S. Have done a lot of work all over the world for many years, and I will be glad to highlight some of the technical issues as it pertains to this textbook. I'll start with an introduction. I'll talk about evaluation and retrofit process. The site investigation and analysis, retrofitting and monitoring. وهو ده بيبين العملية التقنية في التعامل مع damaged buildings. We need first to evaluate the conditions by doing site investigation and modeling and analysis in order to decide whether or not we intervene, and if we intervene, what kind of retrofitting we're going to do. And then if we do retrofitting, we need also to do minimum monitoring in order to decide what we have done makes sense or not, or successful or not. مشكلة إنه there is a lot of people doing a lot of interventions, but these interventions may be harmful to the historic structures. So we need to be very careful on what we do. As you all know, there is significant damage to unreinforced historic structures simply because of their inability to really carry significant loading and their inability to deform without collapse. The load-bearing structures are very unique structures. It's different from reinforced concrete, and the people involved should really have the background of understanding the behavior of these structures and how they respond to loading, and what is the significance of when they see cracking. They get very excited and they think that the building will collapse. But really, there is a lot of alternate load path and robustness of masonry structures compared to, say, reinforced concrete. So we need to take the mentality of reinforced concrete away when we're dealing with load-bearing structures. لأنه without that, that can cause all kind of issues and problems. There are different types of historic structures depending on the era, the type, and the way they resisted the loading. So we need to understand the materials, we need to understand the system, and then when we start to intervene, we got to have compatible materials and looking at how the system is respond to loading and how we will be able to rectify the situation. And that's why in my book, we have to introduce the behavior of ancient masonry to practical engineers. لأنه unfortunately in many countries like in Egypt, and I don't know about Lebanon or Iraq, load-bearing masonry is not part of the undergraduate curriculum. Usually they cover reinforced concrete and steel, but they don't necessarily cover unreinforced load-bearing structures, which really is kind of complicated to deal with. And also there is transition from the ancient to the modern masonry. And we see there are many examples which really from the roughly 1900 to roughly about 1960 or so, which we call it transition masonry. And then there is the modern masonry structures. And in the book in chapter 2, it gives really an introduction into modern masonry and how really masonry being reinforced, how it behaves under loading and cycle loads and abnormal loads. And I have another book on masonry structure. This is the 4th edition. This book has been in the US for over 20 years now, and this is the 4th edition of the book. But you really need to do training of the engineers to understand how these buildings behave before they jump in and then they start doing some retrofitting. Without understanding the behavior, your intervention wouldn't be necessarily an appropriate way of dealing with it. الحاجة الثانية إنه before any retrofit, there should be really proper investigation of the problem. And المشكلة إنه when you really start looking at a structure, you need to be sure that you know the condition of the structure and whether or not you can even access the building, and whether the building is dangerous or not. فالevaluation of the degree of damage are really key issue in order to come up with the proper repair or the proper retrofit. And that's why the evaluation process need to be really considered, and there are investigation plans that you have to follow, and you look to some codes and guideline requirements for evaluation. There are different ways of procedures by which we look at the we call it different tiers of assessment and evaluation, following rather complicated procedures to determine the different types of cracks and damages into different masonry types. There are many types, like type 1 to type 9 of cracking, and each crack has its own significance from the structural safety standpoint.
Yes.
We have in the United States a very good document that will be very helpful for those involved technically in this process. We call it ASCE 41, and it has 3-tier process. And again, I'm not going to go into any detail, but the idea is that when we deal with buildings, we got to classify buildings based on different levels. So some buildings we will go into only screening, and then we make a final decision. Some buildings has to go to tier 1 and then tier 2 to determine deficiency-based evaluation, and then the more complicated one go into tier 3. وهي دي مشكلة في strategy of how you deal with buildings, because not every building is really under the same circumstances to intervene.
It's a problem in strategy.
Right. And again, you know, I'm not going to go into really the different tiers, but again, in the book and in ASCE 41, there are really different steps. Hello. Different steps.
هي لثمانة تأخرت ساعة.
لا هي عبده بعدين تفضل.
محمد اعمل الشباب ميوت بس خلي المحاضر يحكي.
محمد حملوك كل المسؤولية يا محمد.
أنا
تفضل دكتور.
السكرينينج بروسس مهم قوي. ليه؟ لأنه بنعمل بنش مارك بيلدينجز وبنعمل selection of a checklist of each building, and then we start categorize each building of the degree of analysis that we need to do. Some of the buildings could be as easy as we say, hey, you know, there are some minimum damage, and we do it by observation, and the building is safe to come in, and then maybe we do some minimum repair. Some other buildings then will go into the tier 2 and then the tier 3. فدي مهمة في موضوع البروسيس of screening. The guideline, the ASCE guideline, give you default values of some of the material properties that you need depending on the masonry condition, whether it is good or fair or poor. Because when we do analytical modeling of the building, we need to come up with the material properties in order to really predict the available strength. And you can do non-destructive testing. But if the non-destructive testing is not available, then you may go and assume, say, a fair condition and come up with the values that you need for your analysis. لأنه in order to do assessment we need to do actually in situ testing, but also we have to do modeling of the global structure in order to check its stability. The site investigation, there are now many techniques, testing techniques, very sophisticated ways by which we can do in situ testing at the material level, at the component level, and at the system level. And that's covered in chapter 4 in the textbook. There are a lot of testing that we can perform by which we can really determine strength properties and stress strain curve. We can determine the moisture level in the rain penetration resistance, some of the shear strength of the shaft test of the mortar type. We can do even as simple as a Schmidt hammer that many of the engineers familiar with in order to determine compressive strength, and look at uniformity, because not every part of the structure we will be able to test. So we can test certain part, and then we can use non-destructive testing for the rest of the structure to define uniformity of the structure. There are many that you have to identify cracking and different level of damage. There are 15 levels of damage that's identified in the book, and you need to come up on the checklist because each really the level of damage will require different type of intervention. And then if you decide to intervene and do retrofit, then you really have to do retrofitting depending on your observations. There are retrofitting techniques that related to demand, meaning you can increase the demand or you can decrease the demand or increase the supply. So and I'll very briefly go over these 4 techniques. There are techniques related to increasing element strength, and that's very common and known. You can put a jacket or you can add some reinforcing or whatever. And then there are techniques related to increasing structure system stability and integrity. And there are techniques related to improving surfaceability, like moisture, rain penetration, or any other environmental effects. There are so many retrofitting techniques that is available, and it's presented in the book. I'm not going to go over many of them, but for historic structures, you need to intervene without really damaging the historic significance of the facade. So we need to do really internal reinforcing. We do post-tensioning. We can get into, say, a tower, and then we can really post-tension the towers at certain locations internally by drilling in and then doing post-tensioning. We have done that in many towers in the US and in Italy as well. We can do internal reinforcing. We can do internal reinforcing here too. And then we can internal, in a sense that we can reinforce internally, and then we put the mortar so it doesn't show on the outside. As I said, you need to monitor really what you're doing in order to determine whether or not you've done a good job or not. And there are different ways and efforts on monitoring techniques. We can provide sensors in order to, like, the crack, how we see the crack detection, crack width, if it is stable or not. And if it is stable, it's different than if it is unstable. So we need really to, we can do more sophisticated ways of seeing whether the deformation is continuously going on while it is already safe to intervene. We do very sophisticated techniques now. We call it dynamic vibration monitoring, and we can enforce some vibration at the top of the building, very small vibration, and look at the response of the building to determine the overall stability of the structure. Because if you do dynamic testing, you can calculate the period of vibration and the damping characteristics and the stiffness of the structure. If the structure is damaged in a great deal, then there is a significant amount of damping, and we will know right away what level of damage globally the building has. لأنه المشكلة مش في localized damage. Buildings have a significant redundancy, so maybe 1 or 2 cracks in different locations doesn't mean anything. And you may think that if you fix these few cracks that you see, the building is safe, but that's not maybe the case. There may be some damage that you don't see, and you need really to do what we call it global monitoring techniques. It's like building like that, we put sensors in the 3 directions, and then by looking at the forced vibrations, we can really determine the structure characteristics, and then can intervene. And and again, you can really do different ways and different techniques to determine even some localized effects like the crack width and temperature effects. We can do laser scanning actually to look at stressed areas. And as I said, there are so many techniques. Obviously, some of these techniques are very expensive. You are not going to really do that until you really exhaust all the other simple techniques in order to make it cost effective. We have, obviously, we can do radar testing of looking at how the, say, minaret or medana is moving with even traffic vibrations. And then we can determine how this structure will behave in the future. In closing, as you know, there are really many buildings that damage with different degrees, and it becomes overwhelming to really come up with a single solution or one size fit all. It doesn't work. The other thing is proper evaluation and site investigation are key to arrive at suitable methodology for retrofitting. واحنا ساعات بنعمل يعني نفرض even if it is a reinforced concrete, we can do retrofitting of key location or columns based on the analytical modeling that we do, and then we enforce some vibration in the building and see how improvement the building is, so that we can go further in a stepwise way to really make cost-effective repair for the structure. What I would recommend is that really to move forward. That's really the I think what you are looking for is that we will be glad to participate with Dr. Sharif through his company AIM to offer a short course in the assessment and retrofit of historic masonry structures. You can select people to join in it. It will be remotely offered, and it will go through really the details of what I'm very quickly explaining. The other important thing is that we should have resources available to help the practicing engineers in their current effort to assist the retrofitting of buildings. One possible resource that it will be the base for the short course is my recent book. And in this book, they will be really appendices that give the engineer really a checklist, what you're supposed to do when you get in, how you document the observations, how you classify the observations, and it takes you one step at a time in order to arrive to the most practical and cost-effective solution. The bottom line, the more investigation, the more cost-effective you will be able to achieve. فهي دي بقى يعني the key issue, I think, إنه there is no enough funding really to do all, but you need to realize the importance of the structures, and if they are important, then you need to investigate and investigate in a proper way that it will give you a good longevity for the structure, and at the same time it will be cost effective. I did talk with Dr. Sharif that we can make this book available, whether it is in English or we can even translate it in Arabic. Gonna be a tremendous effort to do that, but if there is enough interest in different countries, then we can I can talk to the publisher and we can have possibility of having this resource available to everyone, inshallah. that's what the book is covering. And it has at the end 8 case studies that take 8 projects that we done, me and my co-author, and it take you one step at a time in order to finish the project. لأنه after you do a short course, then you create a team, and then this team will start take the knowledge and take a target structure and really apply the methodology for a couple of structures with, say, help of a consulting team, until you train the engineers. You train the engineers not only by giving a short course, but by case studies and real projects, with the obviously the observation of the consultants or the trainers. These are the appendices that has available in the book that give you significant amount of reference standards and guidelines, masonry building survey forms, evaluation checklist, maintenance checklist, cleaning recommendations, and hopefully that inshallah will be helpful in achieving your goal. شكرا جزيلا والسلام عليكم.